Good morning, friends. Good morning, guys. After many months, actually, I have started recording my voice recording in front of camera on technical stuff. Okay, because I was dissuaded to a lot of other things except technical stuff. So anyway, I'm happy to be back in the technical domain again. So today, the stuff that I'm going to discuss is kind of the usefulness of weak pointer in case of cyclic dependency in C++. Okay, cyclic dependency when one object is dependent on the other, and similarly the other object is also dependent on the previous object. Okay, that's called cyclic dependency in object-oriented domain. Okay, now in case of normal cyclic dependency, there are chances of memory leak. So if we use shared pointers, for example, let me show this with a typical hierarchy of and a family hierarchy. Okay, suppose there is a class called mother. As you can see, there is a class called mother, and it has her own member variables, one son and one daughter. Okay, so suppose we have kept this reference of the son and daughter as shared pointer. Okay, I have kept the son's reference as shared pointer, and I have kept the daughter's reference as a weak pointer. Okay, now then after, because when the mother is born, there is no trace of son and daughter, but then when the son and daughter will be born, they will be born with a reference of the existing mother, of an existing mother. That's what you can see from here, this constructor, right? They are taking birth with the reference of an existing mother. Okay, and then what mother will do after the son and daughter are born? Mother will simply set these member variables with these methods. Okay, set daughter and set son. Okay, now as I have told you that to do the experimentation, I have kept the son's reference, mother having a shared pointer reference to the son. So shared pointer reference is a strong reference. Okay, so whenever as you know, shared pointer, whenever there will be copying of one pointer to another pointer, the shared counter will be incremented by 1. So naturally, when the son will be in the set son method, when the son's reference counter will be incremented by 1 in case mother's son reference is a shared pointer. Okay, so now what will happen? So in the main, what I have done here, as you can see, I have created the mother as it is, and then I have created the son and daughter with the reference of the mother. Okay, so both son and daughter are created with the reference to the mother. See the mother variable here. Okay, and then after they took birth, the mother had set the son and mother had set the daughter. Okay, now what will happen, as I told you, as we have kept the son's reference as a shared pointer, here the son's reference counter will be incremented by 1. Okay, son's reference counter will be incremented by 1 here. Okay, so let us run this application to understand. So what will happen here? So after the son is set, see, after the son is set, son's reference counter is set to 2. Okay, now whenever the main is over, the reverse, the leaf last in first out order, the stack will be unwinded. Okay, and then the daughter was created at the end, so daughter will be removed. Okay, so daughter gone, that's okay. But then son's reference counter, because son's reference counter has become now 2, so it will try to decrease the reference counter by 1 after removing it. Okay, so son's reference counter will be 1. Now as there is the reference counter is 1, so son will not be claimed from the memory, and as a result there will be memory leak of the son, and as son is not created, the mother's destructor will also not be called. So there will be the memory leaks of son and mother object. Okay, so why? Because we have kept the son's the mother's reference to the son as a shared pointer. So as you know, shared pointer means whenever mother will be set son, so the counter will be incremented by 1. Okay. Now I will show you what will happen. So naturally, as you can see, in case of shared pointer, shared reference to the son, only daughter's destructor is called. Now let us change it. So let us change the shared pointer reference to the son to a weak pointer. Now you will see the magic. Okay. So what will happen now? Because it's a weak pointer reference in mother, so whenever mother will be setting the son's reference counter will not be incremented. Okay. So that means it will remain 1 the moment as it was created. Okay. So now if we run it, see after the setting son's reference counter, son's reference counter after setting remains 1. So when the stack is unwinded, so in the reverse order, daughters is gone, and then son's reference counter will be decremented, so it will become 0. So the moment it will become 0, its destructor will be called, and so once the son's destructor is called, the mother destructor will also be called, and so mother will also go out of scope. So there will not be any memory leak. So therefore the weak pointer is a very good stuff, very good tool to control the memory leak in case of cyclic dependency. Jai Hind, Jai Bharat. I hope this discussion will help you a little bit understanding of weak pointer and shared pointer. Again, to recapitulate, the moment we do use a shared pointer, the moment we want to copy a shared pointer, its reference counter is incremented. But if we use weak pointer, it's a weak reference to the to some object managed by shared pointer, but its reference counter will not be incremented. Okay. So that's why when we use shared pointer of mother's reference to the son as a shared pointer, it was incremented to 2 whenever we did the set. But in case of weak pointer, its reference counter was remained as 1. So the destructor was properly called, and there was no chance of memory leak. Jai Hind, Jai Bharat.